Right, so with question 4, we have to do a bit of trigonometry fun. So I always like to analyse what I've got to begin with and kind of make a bit of a plan for how to, substitute and rearrange this so that we end up with the right-hand side. So initially, we're after sines and cosines, and we don't want any of those tans. So what we know is that sine x over cosine x equals tan of x. So what we can go ahead and do is replace the tan x on the top with sine x over cosine x plus 1, and then still keep that fraction sign, and at the bottom replace it as well. So sine x, replace the tan x with sine x over cosine x, and then add on that cosine x there. What I'm going to do is something which hopefully will help you see how to kind of simplify this. At the moment, what I've got at the top is a fraction and a number. What I'm going to do is combine those two together to make it one fraction. So sine x plus cosine x all over cosine x. So all I've done there is basically multiply this by cosine x over cosine x. And then I have the same denominator so I can add them. And on the bottom of the fraction here, I'm going to do the same thing. I'm going to multiply this by cosine x over cosine x, which means I'll get cosine squared x over cosine x. So I'm going to get sine squared x plus cosine squared x all over cos x. All I've done just there at the same time is I've done sine x times sine x is sine squared x, and then cosine x times cosine x is cosine squared x all over cosine x. And what you can see now is I've got this cosine x in common, which we can divide through, and then we end up with just sine x plus cos x all over sine squared x plus cosine squared x, which just equals sine x plus cosine x, because we all know that sine squared x plus cos squared x equals 1. Okay, on to part 2, which is nice because even if you couldn't do part 1, remember you can still use the result from part 1 to do part 2. So what you're going to do when you write this out is take all of that and replace it with sine x plus cosine x. So that means that sine x plus cos x equals 3 sine x minus 2 cosine x. And we're trying to solve that for between 0 and 2 pi. So we're going to do this in radians. Okay, so let's rearrange this to have the sines and cosines on one side. So if I take away sine x and take away cosine x, I'm going to end up with 2 sine x, and I'm going to end up with minus 3 cosine x equals 0. Now, of course, I need this to be in one type of trig function to solve it. So actually I'm going to sort of tweak that again and make that like that. So 2 sine x equals 3 cos x. What I'm going to do is make it so I've got sine over cos so that I can use tan. So if I divide through by cosine on this side, and then divide through by 2 on the other side, I'm going to get that. And sine over cos is the same as tan x. So tan x equals 3 over 2. Okay, so why did I do that? Because I need to solve this in just one trig function. Looking at this, it doesn't make sense to use sine squared plus cosine squared x because I don't have any squared terms. So then I think you just have to build up this kind of recognition of when you get to the situation here that, yep, you could turn it into a fraction of sine x over cosine x to get your tan x. It'll help you solve it. Now we've got this, tan x is 3 over 2, we can go ahead and solve that. So let's do the inverse tan of 3 over 2. And remember, I've told you that when it's in radians, just put your calculator in radians and solve it in radians. Don't try and do any other conversions of it. So if you do inverse tan of 3 over 2, or 1.5, you're going to get 0.983 as your principal solution. And if you check that up here, that is in our domain. It is between 0 and 2 pi. So we need to get our other solutions. And I'm just going to really quickly sketch the tan function again, whoops, for myself. And that just reminds me that if I'm looking at a solution like that, I'm going to have two solutions, and they are going to be 180 degrees apart. In this case here, 180 degrees is the same as pi, because I'm working in pi. So if I just add on pi to my solution, I'm going to get 4.12, and both my answers are in 3 sig fig.